Welcome to this next podcast in this series on Oracle's in-database SQL Analytics. My name is Keith Laker and I'm a Senior Principal Product Manager for Data Warehousing and Big Data at Oracle. In this podcast we're going to look at some examples of how to use Oracle's in-database SQL Analytics to answer some typical business questions. Our first business question is to determine who are my salespeople in each of my sales regions. To answer this question, we need to select the salesperson, region, and sales amount, and we'll order the results set by region. We can use the SQL analytical function rank to help us determine who are our best salespeople. The syntax for the rank function is similar to the previous examples that we reviewed in earlier podcasts. Again, here we're using the over clause followed by the partition by clause to group our data by region and the order by clause to sort the data by sales in descending order. And we've extended the final order by clause so that we organise our result sets within each region by rank. As you can see, the result set is ordered by region and then in descending order the salespeople within each region with the best performing salesperson as the first record in each region. So in East region, Adams is my top performer, and in West region, Donna is my top performer. Of course, we could reverse the ranking process and see who are my worst salespeople in each region, and to do that we simply change the order by clause in our rank function to sort on sales in ascending order. Now let's extend our SQL statement to use some reporting aggregates, in this case some using the over clause, to answer some additional business questions, comparing sales with regional sales and total sales. So here we're computing the total sales for each salesperson within their region, and that's my sales column. The total sales for each region, that's my R sales column, and the total sales for all region, that's my T sales column. So as you can see from the SQL results set, this contains multiple levels of aggregation, and this is all generated from a simple single SQL statement. Obviously at this point it's relatively easy to extend the analysis even further by looking at contributions. How much is each person contributing in terms of regional sales and in relation to total sales? Now going back to our ranking calculation, let's add some additional ranking functions. And just to warn you here, please note that we've modified our original data set just for the purposes of this particular example. So going back to our rank over clause, again partition by region, so we group our salespeople by region and then sort in descending order based on sales. As you can see, in the East region we have a tie for third place between Baker and Donna. And what this means is that Edward is allocated a rank of 5. If you were expecting Edward to be ranked 4th, then we can resolve that particular issue by using the dense rank function, as shown here. Now Edward is ranked 4th and not 5th, and there are probably instances where you'll need both types of ranks because of specific business rules within your organisation, and this is why we provide two types of rank functions. Now let's extend the analysis a step further by using what's called the cumdist function. And this computes the number of rows with a value, as specified in the order by clause, in this case greater than or equal to the current value, divided by the total number of rows in the specific partition. This can be used to select or create a Pareto type result set, where you extract the top 80% or bottom 20% from your data, or conversely the top 20% or our bottom 80% from your data. So how does this work? For the first value, which is Adams, with sales of 200, there is one row with that value or higher. For the second row, which is Connor, with a value of 180, there are two rows with that value or higher. And so we move through our data set. For the third and fourth rows, where we have a value of 150, there are four rows with that value or higher. So each of these row count values are divided by the total number of rows in that partition. And as you can see from this modified set, we've increased each partition to have 5 rows. So the first row is 1 over 5, which gives us a cum dist, as shown in the last column, of 0.2. For row 2, given that we have two values that are equal to or greater than the value shown of 180, we take 2 divided by 5 and we get 0.4. And for rows 3 and 4, there are 4 rows with that value or higher, so we have 4 over 5, which is 0.8. And finally, row 5 is 5 over 5 equal to 1. So now let's change our data set and switch from looking at salespeople to looking at products. The next business problem we're going to look at is how to calculate the contribution of each product in relation to total sales. And to do this, we need to compute the total sales for each product and then divide those sales for each product by the total sales for all products. And there is a SQL Analytics function called ratio to report that will actually do this for us. The highlighted code box there shows this analytical function, ratio to report. And we're using the sum of sales revenue for each product and comparing it to the total for all products, which is why our over clause is blank, because we need to compute the total sales. So just to confirm the details of the calculation, we can see that shoes contributes 22% of total sales. That's to say 100 over 445, and socks contributes 10% of total sales. Now let's consider a different business problem. How do sales compare versus this month last year? And to answer this problem, we're going to use what's called a lag function. Now, using the lag function, we're interested in sales and we want to step back 12 time periods to get to the last year, which is why we need to order the data by the time column, in this case time key. And we'll name this column sales last year. The final calculation is to calculate the change in sales between the current time period and the prior time period, as shown in the final column of our table, sales change. And we can do that by just doing a simple subtraction of sales minus sales last year and renaming the column as sales change. So these examples show that it's very easy to create sophisticated SQL using Oracle's in-database SQL Analytics. Obviously there are lots of different ways to answer these business questions that we've just looked at. However, using SQL Analytics offers some key advantages over other methods. The use of SQL Analytics can enhance the capabilities of your existing tools. By embedding these features within views, you can make the result sets from SQL Analytics available to a very wide audience. For developers, the use of SQL Analytics is going to help you simplify your application code, and it offers investment protection because these features and functions comply to ANSI standards. Learning how to use the SQL Analytics features and functions is minimized because they use a consistent ANSI standard syntax. Most importantly, the Oracle database contains specific optimizations for these features to ensure the best performance. In fact, there really is simply no reason not to use SQL Analytics in your data warehouse projects.